Hello everyone. This is my another video tutorial. That is here I discuss about the FRET. So FRET stand for the fluorescence resonance energy transfer. It is one of the proteomics technique which is used to study the protein-protein interactions. So there are different types of protein interactions which takes place in the cell. To study that interactions, what is the PPIs and how the PPI can be classified on different ways, that are they can modify the function of different protein. They can change their ion contact with each other. They can involve in the various substrate channeling. So this can be studied with the help of protein-protein interaction. And to understand the protein-protein interaction, FRET is one of the most commonly used technique. So here we'll discuss about the FRET. So FRET stands for the fluorescence resonance energy transfer. And this technique is discovered by the scientist Forrester. That's why this technique is also known as the Forrester resonance energy transfer. Another terminology used, that is resonance energy transfer. Simply the resonance energy transfer. And last one terminology used to describe this technique is singlet energy transfer. So we'll see one by one what is the meaning of these all terminologies. So fluorescence resonance energy transfer, here are the four words mainly. That is, first one is the fluorescence, second one is resonance, third one is energy, and fourth one is transfer. So what does takes place in this technology? The energy is transferred from one fluorescence molecule to another fluorescent molecule or another fluorophore molecule. So this technique is basically based on the fluorescence. So fluorescence is a phenomenon which is takes place in the fluorescent molecules, takes place in the fluorescent molecules. So how this will be takes place will describe in short. Before that, in short I explain about the singlet energy transfer. What does it mean? So what are the fluorescent molecules used in these techniques that contain the paired electrons, so whatever the paired electron present in that fluorescent molecule, one will move in the clockwise direction and other paired electron will move in the anti-clockwise direction. So that movement of electron in the clockwise and anti-clockwise direction, that state of electron is known as the singlet state of electron, and that's why this technique is also known as the singlet energy transfer, because the energy transfer is takes place from one fluorescent molecule to another fluorescent molecule. That's why it is called as the energy transfer. But that electron will help in the transfer of energy, and that electrons are present in the singlet state. What is meant by singlet state? I told that. That's why this technique is called as the singlet energy transfer. So now we'll see about what is meant by fluorescence, what is meant by resonance, and what is meant by energy transfer. And at the end of this technique, you can wholly understand about the what does it mean totally. So first we'll see about what is meant by the fluorescence. So there are many fluorophore molecules which are used in the biological system to study the various processes. Like here we can study the protein-protein interaction, and to study the protein-protein interaction we use the fluorophore molecule or the fluorescent molecules. Generally you know about the green fluorescent molecule or GFPs. There are so many variants of GFPs are available that can be used in the biological system to study the different kinds of mechanisms which is takes place in the cell, or to understand the various mechanisms which are happening in the cell. So fluorescence is a molecule which is made up of number of electrons. It absorbs the radiation of certain wavelength and it emits the radiation of certain wavelength. When it absorbs the radiation of certain wavelength, it is present at the ground state. Once it absorbs the radiation of certain wavelength, it moves to its excited state. It reaches to its excited state. And this from this excited state it come back towards its the ground state, and when it come or when it move from its excited state to ground state, it again emits certain wavelength of radiation. So, because protein molecules are not majorly present in the excited state, they want their stability. That's why they again move from excited state to ground states. So, when they move from the excited state to ground state, it again emit the radiation of certain wavelength. So, this emission of radiation is again absorbed by the another fluorescent molecule which is present next to the first fluorescent molecule. So what happened here? The energy is transferred between the one fluorescent molecule to the next fluorescent molecule, and that is called as the resonance. That is called as the resonance. And the wavelength has the reverse proportion with the energy. If the absorption wavelength is more and emission wavelength is less, it means that it absorbs the higher energy and it emits the lower energy. It has the reverse proportion. Wavelength and energy has the reverse proportion with each other. So here in this technique, what happened? The energy is transferred between the two fluorescent molecules, and the one fluorescent molecule which is labeled with the one protein, that is called as the donor, because it emit or it transfer the energy from itself to the another fluorescent molecule. And the another fluorescent molecule or the another protein molecule which is labeled with the second fluorescent molecule is known as the acceptor, because it accepts that energy from the donor fluorescent molecule. So here in this diagram, this is a S0 is the ground state of the fluorescent molecule. It absorbs the radiation and it will get excited. That is S1 is the its excited state of that particular fluorescent molecule. It come back to its original state or its ground state because they want their stability. And during this step, it emits the energy to the next fluorescent molecule, that is called as the acceptor fluorescent molecule, and that process is known as the resonance. Hope that you understand about the what is meant by fluorescence, what is meant by resonance, and what is meant by energy transfer. So fret is one of the distance dependent phenomenon. So I told that the energy is transferred between the two fluorescent molecules. If the distance between the two fluorescent molecule is more, then it is not possible to transfer the energy from this fluorescent molecule towards the second fluorescent molecule. If the distance between these two fluorescent molecules is less, then only we'll get the overlapping spectrum between these two fluorescent molecules. So that's why it is called as the distance dependent process. And it is a physical process. It is a physical process because this technique is used to study the protein-protein interaction. When two protein get interact with each other, this is called the physical interaction with each other. But it has the high specificity, which include the various hydrophobic interaction, various hydrogen bonding. So that's why it is a strong interaction between the two different types of protein. That's why it is called as a physical process and distance dependent phenomenon. Next, we'll study about what is the principle of this FRET technology to study the protein-protein interaction. Here you see the two diagrams. First one is this and another one is this. I already told that the fluorescent molecule, which are the fluorescent molecule, use two different types. Suppose there are two different types of fluorescent molecules are used to study the protein-protein interactions. That two fluorescent molecule must be very close to each other. Then only the emission and absorption process will take place within these two fluorescent molecules. Suppose there Here is these are the two proteins, for example, protein X and protein Y, which are labeled with the two different fluorescent molecule. One protein, that is protein X, is labeled with the CFP. Generally, the two fluorescent molecule is used to study the FRET between the two protein molecules. That is, first one is the cyan fluorescent molecule and another one is the YFP, that is yellow fluorescent molecule or yellow fluorescent protein. These two fluorescent molecules are the variant of green fluorescent protein. This is of cyan color, this is of yellow color. So these two fluorescent molecules are used and linked or labeled with the different types of protein for which you want to study their interaction, for which you want to study their protein-protein interaction, what type of interaction takes place between these two proteins. So for example, you choose the protein X and protein Y. Protein X is labeled with the CFP and protein Y is labeled with the YFP. So when these two proteins have interact with each other, then only these two fluorescent molecules come close to each other. So CFP absorbs the radiation of certain wavelength, it will get emitted, and the absorption and emission of the certain wavelength by this fluorescent molecule is takes place when this fluorescent molecule leave its ground state to excited state and when it come back from its excited state to ground state. So at this stage the absorption and emission of the certain radiation will take place by this fluorescent molecule. Similarly, this YFP absorb the wavelength of certain absorb the radiation of certain wavelength and emit the radiation of certain wavelength. But keep in mind that the emission wavelength of this CFP must be the absorption wavelength of YFP fluorescent molecule. This is one of the requirement of this FRET technology. Whatever the fluorescent molecule you are choosing to study the protein-protein interaction between the two different proteins, that fluorescent molecule must have the overlapping spectrum. Must have overlapping spectrum means here you can see that the green portion, that is you get the overlapping spectrum between the two fluorescent molecule, that is CFP and YFP. When you get like this graph, that is overlapping spectrum, when the emission wavelength or the emission energy of one fluorescent molecule is the absorption wavelength of the second fluorescent molecule. So the two different molecules are used, for example CFP, YFP, which is labeled with the two different proteins for which you need to understand the protein-protein interaction. The donor fluorescent molecule or the donor fluorophore molecule is excited and then transfer energy directly towards the acceptor fluorophore molecule, that is YFP, and then only it emits the photons. It emits the energy in the form of photon. Thus, the emission spectrum of this donor and the acceptor will get overlapped with each other, and then only the FRET occurred. Here you can see that these two protein is not interact with each other. There is no interaction which takes place between these two protein, and here you cannot get the overlapping spectrum because the emission wavelength of this CFP is not absorbed by the YFP. So in second diagram you can see that the CFP and YFP, two fluorescent molecules, come close together. I already told in the introductory slide that it is a distance dependent phenomenon. So here is the distance between the two molecules is more. So because of the more distance or because of the much more distance between the two molecules, you can't get the overlapping spectrum, because whatever the energy or the radiation emitted by this CFP will not get absorbed by this YFP, because there is a much more distance between that two fluorophore molecules. So when this fluorophore molecule come in close together, but when it will come in close together, when there is an interaction between the two different protein takes place, then only the two fluorescent molecule with this two different protein molecule comes in close together. And once it come in close together, you will get the overlapping spectrum, because the distance between the two fluorescent molecule is less, so that whatever the energy emitted by this first CFP fluorophore molecule, it will get absorbed by this YFP molecule, YFP fluorophore molecule. So we'll get the overlapping spectrum between these two proteins. But when it happens, when two proteins which is labeled with these two fluorophore molecules get interact with each other, they come close together, and then only you get the overlapping spectrum like this green color. So this is about the principle of FRET. Next, in detail we'll see about the what is the mechanism of FRET. So I already told that the requirement of FRET. The requirement of FRET. The two molecules, that is the interacting molecules, it must be less than 10 nanometer apart. Means the distance between the two molecules, whatever the interaction takes place between the two protein molecule which is labeled with the fluorescent molecule, the distance between that fluorescent molecule must be less than 10 nanometer, or it should be 100 angstrom. It should be 100 angstrom. Then only you get the overlapping spectrum. Otherwise, you can't get the overlapping spectrum, and FRET was not occurred. FRET will not occur. But to study this mechanism, whatever the proteins we are using to study the interaction, that two protein must be labeled with the two different fluorescent agent or two different fluorophore molecule, and that two fluorophore molecule must have the overlapping spectrum, must give the overlapping spectrum. When they get the overlap spectrum with each other, when the emission wavelength of first fluorophore molecule is similar to the absorption wavelength of the second fluorophore molecule. Suppose in this diagram you can see that this is a protein X which is labeled with the YFP fluorophore molecule. This is a protein Y which is labeled with CFP, and here the objective is to study the interaction between these two proteins, that is protein X and protein Y. So to study the interaction between these two proteins, we label these two different proteins with two different dyes. Say for example YFP and CFP. So when this mixture is allowed for some time, if there is an interaction takes place between these two proteins, if these two proteins may involved in the similar pathway, may have some interaction with each other, may have some ionic interaction, some bonding with each other, then these two proteins come close together each other, and once these two proteins come close together each other, automatically whatever the fluorescent molecule we are labeled with that this protein will also get come close together, and automatically the distance between these two fluorescent molecules is less than 10 nanometer or less than 1000 angstrom unit. So this is a basic requirement of FRET. Whatever the fluorophore molecule you are using, it must have the overlapping spectrum. It must give the overlapping spectrum. Means two proteins tagged with the two different fluorophore, and the emission wavelength of one or first fluorophore must overlap with the excitation wavelength of the another fluorophore molecule, and the distance between the two interacting molecule is must be less than 10 nanometer. These are the two basic requirements of FRET. So we will study in this diagram what is the mechanism of FRET. So here you can see that the protein X is labeled with the CFP, protein Y is labeled with the yellow fluorescent protein. So the absorption wavelength of CFP is the 440 nanometer, and the emission wavelength of this protein is the of this fluorescent molecule is the 490 nanometer, and this CFP is labeled with the protein X. And another YFP fluorescent molecule have the absorption wavelength or the excitation wavelength of 490 nanometer, and it emit the wavelength of 527 nanometer, and this fluorescent molecule is labeled with the protein Y. So here we need to study about the where the interaction is takes place between the protein X and protein Y. If there is any kind of interaction will takes place between these two proteins, then only this means the interaction takes place between these two protein means that these two protein X and protein Y is come close together. Once the protein come close together, they interact with each other. This fluorescent molecule, which is labeled with this respective protein, it also get come close to each other. So here you can see that the emission wavelength, that is 490 of the protein CFP, is the absorption wavelength of the YFP. So here you can get the overlapping spectrum. But when did you get the overlapping spectrum? When these two proteins come close to each other, when these two proteins interact with each other, then only you get the overlapping spectrum like this. You can see in the pair. These two protein X and protein Y come close to each other, then only the fret occurred. You can say that then only the fret occurred. Then only the energy transfer takes place between this fluorescent molecule towards this fluorescent molecule. Otherwise, if the distance between these two proteins is more, these two proteins are apart from each other, the distance will be more than the 10 nanometer, then also the distance between these two fluorescent molecule is more. If the distance is more, whatever the energy emitted by this first fluorescent molecule, it is not get absorbed by this second YFP protein, because there is a much more distance between these two fluorescent molecules. You can't get the overlapping spectrum. So that's why it is called as a distance dependent phenomenon. It is more important to understand what is meant by the distance dependent phenomenon. So this is all about the mechanism, principle, and the general information about the fret. When you study any kind of technique, you first understand about the what is the meaning, what are the words they say itself about that. So there you can get a more easy understanding about these techniques. Likewise, whatever the video I will prepare for you, I explain it from whatever the words are included, whatever the name itself suggests their meaning, so that you can get easily understand about this technique. Hope that you understand all this, and it is will helpful to you in understanding about the fret technique and how it could be useful in the study of protein-protein interaction. Thank you so much.